right. How's everybody doing? I hope you're all well. I hope you've had a good lunch, and I hope you've had a first good day and a half of the conference. My name is Nick Jackson. I'm a developer advocate at HashiCorp. I'm also I suppose my experience is a software engineer, and that's the way I'd like to kind of keep things. Something that I've done for more years than I'd like to remember, but certainly my gray hair gives that away. What I want to talk about today is something that I've struggled with for a long time through the varying jobs in my career, which is how do you get access to infrastructure to be able to play with things and to be able to kind of experiment easily. And I hope that I'm going to show you some techniques, which definitely works for me, it's something I use every day, that'll help you too. Now, why should you care? And I think this is very pertinent for anybody who's building modern applications or playing around with modern infrastructure, is that we kind of started off at the dawn of time with the monolith. And like every few years, you're going to believe the hype that microservices are not the thing. It just happened last week, and everybody's going to go back to the monolith. This happens. Everything is cyclical. But the dawn of time, we had the monolith. Now, unfortunately, there was a thing called a customer, and the customer appeared and sadly kind of increased the demands on things. So Adam and Eve decided that they needed to scale that monolith. But unfortunately, they kind of were looking for some solutions, and well, you know, like Eve was just like, hey, look at those apples, they look really delicious. So Adam and Eve, they decided that they would scale the monolith, and they were looking for these alternate techniques. They ate the apple, the forbidden fruit, and what happened? Well, the kind of the biggest atrocity in the world was delivered to us all, which was XML. And SOAP-based microservices and object-oriented, and then like anybody who's worked through this stuff, has anybody dealt with SOAP? And okay, you know, like it was good for the time. But there are modern techniques which have kind of superseded it. Like I'm flippant, but the key thing is, SOAP was the thing that made me realize that I could have two applications which were connected together. It was like fabulous. I was working at the time in VB.net, working for an events-based company. And what I wanted to do is I wanted to process some images. Well, of course, like VB.net didn't have, sorry, it wasn't even VB.net, it was just VB. It was using ActiveX COM object inside of ASP2, so it was previous to VB.net. Anyway, there was no image processing. So I looked at around, and I'm looking for a way to process images, and JAI, so the Java Advanced Imaging, was probably the best way to process images at the time. So I'm like, well, how do I make this Java application work with my monolithic application? And the answer was SOAP microservices, and it worked really well. And I built microservice. It was two connected systems. I'm not going back there, though. Now, in an attempt to tame the toil that we had, what we did was we started looking at things like cloud. So we were looking at the monolith and our service-oriented architecture, and when we had problems that we needed to tame this thing. Running on like tin or kind of physical machinery was fine, apart from the 3-month lead times. The other thing that was kind of not fine was the fact that it took a lot of effort to build and redevelop machinery. And I think where we are right now is in a much better place for that. We kind of advance things a little bit further, and the autoscaling groups are playing all manner of pain. You've got this very sort of dynamic and sort of ephemeral approach to your infrastructure. Nothing stays the same. Everything is changing. The addresses are always changing. And unfortunately, that unleashed the second biggest problem that the world has ever known, which is DNS. Now, the problem was that the DNS was kind of taking an approach of a mentality where things are like, hey, well, they don't change very often. You know, a machine is set in stone. My house is a great example of something that works with DNS. It hasn't moved in 100 years. My cloud infrastructure, it can change every 20 minutes. And DNS is an incredible tool, but didn't necessarily give us the ability to deal with this highly sort of shifting and dynamic infra. So we kind of had to start to think about how we do things differently. We had to start thinking about, well, should we do, like, how do we do load balancing when addresses are changing? So we're introducing things like service catalogs and stuff like that. One of the kind of the common patterns, certainly something that I used, was hub and spoke load balancing. And this works perfectly well, but you do have an additional sort of latency. And some people, well, they're like, hey, we're getting with a load balancer per service, right? So you have this sort of pattern here. But people are not content. Oh no. We're not content that this mess that we've created is going to be good enough for future generations. We need to double down. We need to make our services smaller. We need to make them more distributed. We need to make them more difficult to connect. So we invented microservice architecture. And again, like, I'm being flippant. I'm a big fan of microservice architecture and the benefits that it brings for teams, but it does cause problems with infrastructure. To help this, we invented Kubernetes. Help? Complicate? Like, it solves the problem. It introduces a burden for us of something that we extra now that we need to learn and have to kind of understand. Because if we don't understand, if we don't have mechanical sympathy for the infrastructure that our applications are running on, it doesn't help us when something goes wrong. We need to debug it or we need to diagnose a possible problem. So that's it. I'm done. I'm done with the slides. You got to stay for another 33 minutes. I'm sorry about that. Let's dig into something. I want to kind of, so, the crux of that story is that as an application developer, over the last 20-odd years, I've had to learn a lot. I started out when I first sort of started getting into programming, and I had a PC, I think not a very good PC. It was like a 486, 25 megahertz with 4 megabytes of RAM. It ran Doom. It was fine. But then kind of things start progressing. Like the first application that I developed and built professionally was running on 2 Sun Solaris boxes, 2. And that was for Formula One. Built the first website for Formula One on 2 Sun Solaris boxes, which were probably less powerful than your iPhone or your Android phone. But when I moved into that area, I had to learn something new. I'm moving from a Windows domain, and now I'm dealing with Linux. So I'm running this LAMP stack. I'm running Apache and PHP and MySQL, and it's great. But as a sort of an application developer, I need to, I don't have a Unix box. I've got my Windows machine. Where am I going to get the access to this infrastructure? And it was always a bit of a challenge. As things have kind of progressed down that line, I've had to kind of learn, well, how do I deal with Docker? How do I kind of understand how my application behaves and can integrate with dynamic service discovery? How does it work on Kubernetes or sort of modern schedulers? And I think I've got a technique for you. And it's pretty cheap. Free cheap, which is always the best cheap. Originally, when we're kind of like hypothesizing about sort of how to learn this stuff, I've done stuff in the past with kind of like Raspberry Pis. I have a few of those at home that I play around with. I've used cloud compute, so I've kind of kicked the tires on using like DigitalOcean Droplet and other resources in Amazon and Azure and GCP and things like that. But the core thing that I kind of keep coming back to really is around sort of accessibility. It's about, I want to experiment, so I want to work fast. And for me, when Docker came out, 10 years or so ago, it was immediately giving me the ability that I can now run this, Postgres server, which is running in Linux-ish, and I can run it on my Mac. And I can run an Apache server, an Nginx server, and I can connect all of these things together. And that's kind of what I'm going to show you. And that plus some tooling that I've written, which I think makes it a little bit easier. So let's dig in. So the first thing that I think is really, really interesting is that when you kind of look at what is a virtual machine. So a virtual machine is kind of like, let's say, a Linux distribution. Let's take, Ubuntu. Now, if you're going to create an Ubuntu instance in the cloud, you're going to have the ability, it's going to say like, hey, you can create this Ubuntu instance, and then you can do some stuff to set up some software, you can install some packages, and you can configure it. And you can do that through like Cloud Init. Now, when you create that virtual machine, the cloud is basically giving you a blank machine, which just has the Ubuntu instance on it. You can actually achieve something very, very similarly with using Docker, which you can then run on your local machine, which means that you can actually spin it up and kill it, and you get a very, very fast feedback. It allows you to kind of experiment. So kind of just looking, I'm not going to dwell too much on this, but I think it's relatively interesting. If we kind of look at the sort of the basis of a Docker file, then what we've got is the ability to kind of derive a Docker file from Ubuntu latest. So that's going to kind of give me a base Ubuntu instance that's going to run in this container. And like you all know what containers are, right? I assume that. Have you all used containers? All right, brilliant. And then, in a similar way that I would be kind of in my Cloud Init script, I'm going to do some apt updates. I can do the same inside my Docker file. So here I'm going to update apt. I'm going to install OpenSSH server, supervisor-d, and zip. Now, if you've kind of used to Ubuntu, generally when you're kind of trying to create long-running applications, you're going to be using something like systemd. Systemd doesn't work too great with Docker. So I always use supervisor-d. Pretty much the same thing. It's a sort of a daemon management package, but it allows me to kind of have fairly low friction and portable experimentation. So I can kind of set that up. Now, then what I can kind of do is I can also, is the same way as I'm going to do my Cloud Init script, I can install some software. So here, I'm going to install fake service, which is a fake service. And I'm also going to install HashiCorp console. So that setup there is pretty kind of, pretty straightforward. Exactly the same as I would do in my Cloud Init script. Slightly different syntax, but. And then, I'm just going to kind of set it up to run supervisor. So this Docker file here is actually going to give me a fake virtual machine that I can then configure SSH to, and I can play around with. It's a nice kind of base image. So let's have a look just quickly at the supervisor-d file, which I'm going to use with this. And it looks like this. So again, there's nothing particularly special going on there. Supervisor is very similar to systemd units, not 100%, but as I say, the benefit is that you can run supervisor in a non-privileged Docker container, whereas you can't with, or at least you couldn't last time I tried with supervisor. Systemd. So we're setting up those services that we're gonna run. Now, if I want to build that, then it's pretty straightforward. You're just going to run docker build. Who hasn't done a docker build? Run a docker build command. Everybody's done it pretty much, right? It's fairly sort of standard approach, and it's fast, and it caches locally. So any mistake that you make, well, you just go back, you correct it in the Docker file, and then you run it again. So I'm not going to run that because I just ran it this morning, so I don't want everything's cached. I don't want to burden the internet. But that's kind of like enough, right? We've now got our fake Ubuntu machine. So we need to run it. So how are we going to go about running it? And I think this is where we start to have a little bit of complexity. Because if you kind of look at the Docker way of doing this, which is perfectly good, like I used this for many, many years, you can use something like Docker Compose, and this is going to allow you to spin up multiple Docker containers in a single go. Docker Compose is a fabulous tool, absolutely fabulous. There's only one problem with Docker Compose, and that's dependency. And that kind of Docker Compose assumes that you just want to kind of like spin everything up at once, And when you're kind of building complicated infra and you're trying to experiment, you can't always do that because you might want to spin up, in our instance, our virtual machine, and then I want to drop my SSH key onto it, but I've got to generate the SSH key. So you end up with a kind of a quite complicated, convoluted bit of bash that wraps around this. So in its simplest iteration, Docker Compose, fabulous, absolutely fabulous, really easy. But when you start to do things like, well, I want to generate an SSH key, it's not easy to do that from Docker Compose. I mean, I can create another sort of application, and I can run a command, and mount a file, so that, things like that. But then we're like, well, how do I install the SSH key onto the machine? And there's no really easy way to do that. I've got to run a command to run it into authorized keys. And to do that, you end up with a bash script. But the bash script becomes quite complex because the dependency. I don't know when the key exists, so I end up putting a loop to wait for the key to exist before I can then run the command to add it to authorized keys. And this was exactly the problem that kind of Erik and I had when we created something which kind of wraps all of this up, wraps up the kind of the process around Docker Compose and this process to allow you to iterate really quickly. And fingers crossed, that's what I'm going to show you now. And I say fingers crossed because it's going to be a live demo, which means there are a lot of areas that can go wrong. One of them being that I could stupid. I'm pretty good at that. Okay. So let's dig into this anyway. So the tool that we're going to use is JumpPad, free, open source, not a HashiCorp tool. It's something that literally I hack on in my spare time to build and play around with infrastructure. So at the core, what we need to create is a network. So we're gonna use this syntax here. If you've kind of used Terraform, has anybody used Terraform before? Okay, marvelous. Then you'll be fairly familiar with this syntax because this is literally where I stole the idea from. Please don't tell my employer because they might try and sue me, and that would be really uncomfortable since I still work for them. But we didn't steal Terraform. What we did was we stole the inspiration around the configuration language and the dependency because it just works really well. So in terms of what we want to do is we want to build these higher level of abstraction. So I can create a network and I can define a resource network. And what this will do is this will create me a Docker network. Because again, if I'm doing my experimentation with infrastructure, I might want to be able to kind of figure out how things connect together. So I might have multiple networks, multiple subnets, all of those kinds of things. So we're going to do that. And then we need a certificate. Now, the certificate, the key, the SSH key, again, I've done this so many times that rather than shelling it on the command line, I just create a resource. So the resource certificate CA, which actually will generate me an X509 certificate authority, also generates a private and public key. So it's badly named, but it does exactly what I need. Now, where it kind of comes down to things, you think, well, right, I'm going to run my application. I want to expose a port to my local computer. How do I know if that port's going to be used or not? It's a good question, right? You could have something running. So the kind of the way that I generally get around this is just to use a random port. So in kind of JumpPad, we've got this resource which allows us to generate random numbers, and we're going to use that to generate our port. And then finally, we can start to look at our application. And this is our container. So it's going to look like this. So I'm going to call it VM1. I'm adding the network. Now, what this syntax here does, it's exactly the same as if you use Terraform. It's interpolation. So we're referencing a variable. The variable is going to be network. Until the network has been created, we will not sort of create the container. And why did it do that? And then if we kind of go through and look at some of these sort of the other elements, we can specify the image, we can mount some volumes. So I'm going to mount an init script. I'm setting those ports. And again, all of that is going to be defined. Now, things kind of like come down to kind of when you want to set this up, we need to think about that VM init script. So how do we do the VM init script? So what we can do is we can use a template resource. And a template resource allows us to just generate a file. So in this instance, what I'm doing is I'm generating my script, which I can run on the VM, which is going to add my key to the authorized keys. And because I'm kind of doing this and using this interpolation, then I know that this script will not run until the key is being created. And then to actually get that onto the machine, well, what we can do to get it onto the machine is I can use another resource, which is a kind of just a higher level of abstraction called remote exec. And what this allows me to do is it allows me to run a command on that Docker container that I've created. And that's kind of like all we need to do to define that resource. So assuming that I haven't made a typing mistake, and that would be very unfortunate because I'm using mostly snippets, but there's always an opportunity. Let's create that. So I'm running the command jump JP up, jump pad up, and what that's going to do is it's going to read the configuration, and it's going to create me a Docker container. Now, the astute of you will see that it hasn't actually created the Docker container, and that's because I've missed a step. So let's go back and do that. So we've created this here. Now, this virtual machine resides in a folder called VMs. Now, this is actually a module. So again, stealing another one of the amazing bits of Terraform, we have this concept of modules. So in terms of my file here, if I got light shining in my eye. You have to apologize. I have to apologize. Whoops. Oops, no, that was not what I wanted to do. Where's my network? What I need to do is add the module. So the module, because it can reference sort of other elements, so we can make things reusable. So the VM that I'm creating, well, I can use it time and time and time again. So we can run that. Let me just comment that line out. We're not going to use that right now. And let's just double check that I've not made any mistakes, and we'll run that. So this is running, it's generating those keys, it's set everything up, and we do now have a virtual machine. So this is good. Now that virtual machine should have already been provisioned with the SSH key. So we should be able to log into it. Now, I don't know what the port is. I don't know what kind of any of those kind of bits and pieces are. So what I can do is I can actually read those outputs from the module, and we can kind of do that by defining some output variables. So let's do that. And then we'll run the command again. I'm going to clear this. Oops. And we can now see those. So we've got I create one which actually is a helper around the SSH command. So let me just SSH command. I can grab that there. Let me copy, paste it. Do I want to connect? This is good so far. Excellent. So now I'm in my fake virtual machine that I haven't spent a single cloud dollar on. And we're going to move on with this. We're going to make this much, much bigger. So this is great, right? Like, so in terms of the experimentation, this is going to be incredibly quick to spin up. This MacBook that I'm using here is about 6, nearly 7 years old. It is not a modern computer by any standards. 16 gig of RAM and some random Intel processor that I can't even remember the make of. But I can still create multiple nodes and multiple virtual machines on my local computer. Now, what I kind of really want to do, though, is I want to kind of spin up multiple machines. So what I've got here is I've got another file, and this file here just contains another virtual machine. So let me I'm going to rename this, and we're going to run that again, and we're going to then add 2 virtual machines to our estate. So I am going to just JP up, and I'm going to bounce over there, and now I've got 2 virtual machines. So that's pretty quick. But the whole kind of point around this is, well, why do I want 2 virtual machines? I want 2 virtual machines because in my hypothetical scenario, I'm trying to kind of discover how multiple instances of my application behaves. You know, like the typical scenario is that you have multiple applications in a single database. Now, your application on a single instance to a single database might be fine. 100%, no problems at all. You add another instance to that application using the same database, and then all manner of problems can break loose. Because you've got instances of kind of like, you know, one application takes out a table lock, the other one's trying to write to the table at the same time. You're not aware of this kind of concurrency, and it can lead to very strange and sporadic behavioral problems in your applications. And of course, if you're like seasoned at dealing with distributed systems, you know what to look for, but it can be difficult to kind of do this experimentation, to kind of simulate these conditions in a way that's cheap and easy. So let's look at that scenario, and let's look at how we could create a load balancer using Nginx. And we're going to use exactly the same sort of techniques that we've just looked at. So again, I'm going to create an Nginx template. Now, the Nginx template that I'm going to use is very straightforward. It's going to listen on port 80. I am going to define 2 backends, which are the 2 virtual machines that I've created, and I'm using their internal references. Now, this works fine because I know what those locations are. We're going to get to the problem when I don't and how we can solve it in just a moment. But for now, this should work for us. And then what I can do is I can define my Nginx resource. So I'm just using the container Nginx, which is already pre-built for me. I'm using some supervisor config, and all that is doing is just starting Nginx. And then I'm going to add my configuration to it there. Now, if I go over, and that again is a module, so I need to add this as a module. So I can do that like so. What we're gonna do is copy pasta. So let's copy the VMs module. Let's paste it here, and we're gonna rename it. So we're gonna call it Nginx, and everything else should be okay. So JP up, everything is going to run. I'm going to bounce over to Docker, and I have an Nginx instance, which should be load balancing to my 2 virtual machines. This is where things can go wrong. Curl localhost, and it is working, so that's a relief. So if I refresh this a couple of times, you're going to see there, you know, it's going VM2. It's just doing basic round-robin load balancing. I've set all of this up. It's running like super quick, super easy. Let's level it up a little bit further, because this kind of learning process, for me, I remember sort of about 5 years ago when we started building microservice systems, this works great when you know what the locations of your machines are. But if you're running in an autoscale group, if you're running in something which doesn't have that capability, you need to be thinking about using other tools. And the solution at the time for us, which is a solution I still believe in, was using Console, HashiCorp Console, as a service catalog. So let's see how we can now build in our lab environment, add Console to our lab environment, and how we can then configure our Nginx load balancer to use console. So now we've got a pretty kind of nicely dynamic, but still running local system. So the first thing that we need to do is we need to add a kind of configuration. So if I open up my virtual machine again, then what I want to do is I want to kind of register a service. So let's use a template. And what that template's going to do is it's going to do my service registration. Now, the console agent that I've got running in my fake virtual machine is going to pick that up, and it's going to do some stuff. I'm going to leave that on the floor to run everything. Now, in addition to that, what I need to do is I just need to map that into my VM. So let me just, oops, that was not what I wanted to do. Sorry, there's a light shining in my eye, so it's making it difficult to see my screen. It's easier when I look at that one. Let's do the same thing to sort of Nginx. Let's have a look at our setup for Nginx. Now, what we want to be able to do again is we want to kind of just register that service. So let's do that. And we're going to create the same thing, so we're going to register Nginx with console as well. And then what I'm going to do is I'm going to use console template. So rather than generating the configuration files by hand, I'm now setting up my system to do what I would actually do in production, which is I would have console template, which is generating the Nginx configuration file for me using this templating tool, the console template. And actually how that changes the static Nginx template means that it now looks like this. So we're now able to use the dynamic service catalog that we're going to add in a second. We can iterate over that, and we can dynamically write out the backends. So even on our little test system, it's still going to be doing the same stuff that the production system is going to be doing. Now, what I need to kind of do is let me just replace my Nginx instance, and I'm going to do that rather than modify it. But all I'm adding is changing the systemd config, and I'm adding an additional volume. So the static stuff can go by. And now let's add our dynamic container. Okay. So let's have a look very quickly at the systemd config so you can see what's now going on in our system. Sorry, supervisor config. I even say it myself. So what we're going to do is we're running Nginx. We're running console agent. And I don't want to kind of get into how to use console. That's not the purpose of this talk. But I'm running console template as well. So it's like I'm setting things up as I would in my production environment. And well, I need a kind of a console instance. So what I've done is I've created a module, and I don't want to get into that because it's literally exactly the same setup as I've shown you. I'm creating containers and networks, and I'm configuring it, but I've got this little module here which allows me to run console. So I can just add it to my setup. And I'm going to do that like so. If I can remember. Okay. So let's just copy this. And we're going to configure it. So console. And it has a network, and it also has a property on a variable which I think is called client nodes. Let's have a look. So dig into that. Not nomad, console, variables, console nodes. Okay. So I'm going to set that, and we're just going to create a single node instance because that's more than enough for this example. Okay, so I've got that. I've got all of those things. I need to specify the location of my console server, so I can add that as a variable to my modules. And again, because of that, like interpolation, nothing's going to run in terms of my VMs until I create my other stuff. Let's destroy everything that I've got running so far. So I'm just doing JP down, it's all gone. So let's now do JP up. And this is going to go through and it's going to, okay, so we've got a typo. Where's the typo? Nginx line 47. Oh, well, that looks very wrong. I'll tell you what, let's clear this down. Because I only have 4 minutes left. Okay. Okay. And I don't recommend being 2 meters tall and trying to type on a lectern that is suitable for somebody not 2 meters tall. Let's run this. JP up. All right. So we're creating that infrastructure now. So we've got our servers, we've got our Nginx instance, we've got our virtual machine. So we've now got console everything running. And if I go over to the console UI, you'll see that I've now got my Nginx instance referenced. I've got my virtual machine there as the nodes. If I look at my service, you can see I've got 2 API instances, 1 and 2, and the Docker network locations for them. So again, you know, like exactly how you would have in your production setup, but everything running locally. And if I curl localhost, then you can see I'm hitting VM1, I'm hitting VM2. So now the configuration is being 100% dynamically generated, and we can kind of see that running there. And I kind of want to prove this to you. No, I'm not cheating here. If I go into Nginx and I go into the terminal, and this is going to be super small, so it probably does look like I'm cheating, etc. Jeez. Gosh. Nginx and confd. So there's the template that we wrote, and this is the dynamically generated configuration file. So every time that my virtual machines change, that'll get regenerated and Nginx will get reloaded, just like a production system. But what about if we want to use a scheduler? Maybe you're using Nomad, maybe you're using Kubernetes. Well, we can do that too. So let's have a look at our Nomad setup. So our Nomad setup looks like this. And it's going to look pretty familiar. Now, I've created enough Nomad clusters to know that I don't want to have to do it manually every time I need to create a Nomad cluster. So what I've done is I've wrapped that up into this abstraction called Nomad cluster. So this is going to generate me a dev-worthy Nomad cluster running in Docker, and it's going to spin it up. 3 client nodes I'm going to run with this, and I'm going to install the API job. So let's just do that. And in the 20 seconds that I've got, we can do it. JP up. All right. Well, that's working. So let's go over to, we can see that we've got our Nomad instance come up. So let's refresh this Nomad UI. All right, that hasn't come online yet, but we'll see this sort of come up in just a second as it's kind of initializing. And eventually, there we go. So now we've got our Nomad cluster up. And on our Nomad cluster, because I configured that it should have a job installed, we can see that the job is currently running, and it's now completed. And JumpPad knows this, so it's finished. So if I do, no, I don't want to do that. If I clot, I'm sorry they couldn't get anybody who could type. They were all available. Kill localhost. So now you see, what I'm hitting there is one of the clients. So it's got the reference of the Nomad client. I'm running the reference, my API is running through there, hitting a VM. So I've now got those two Nginx instances and my Nomad cluster all in sync, all set up, all running locally, all spinning up within under a minute. And if I do JP down, then it's all going to get deleted again, just as quick. So for fast iteration, for kind of rapid prototyping, my personal opinion is this is absolutely the way to go. It allowed me to learn infrastructure, allows me to experiment with systems, allows me to model behavior in my application. And the kind of the demo that I've just shown you and all of the bits and pieces, if you should be able to get to it on there. It's just in a GitHub repo. And I have a couple of minutes for questions, so I'd be glad to answer anybody if you have any questions. And I can't really see if you've got questions because I can't see the light. Nobody got any questions? Oh, you have thank you, you got a question.
I want to know your opinion about...
Oh, of course, sorry, I was just going to repeat the question.
I just want to know your opinion about why would I use this instead of using, for example, a local Kubernetes cluster with Terraform or something like that.
So you can do that, and actually I do that quite regularly. What I actually do is I use JumpPad to create my Kubernetes cluster in Docker. JumpPad has got the capability to create Kubernetes clusters as well. That allows you to iterate perfectly fine. The kind of the core problem that I would run into is that specifically on the stuff, well, the environment that I was working in is that I didn't always just have a Kubernetes cluster. I had the Kubernetes cluster, some virtual machines, or other bits and pieces. Now, even with that approach, with using sort of like say Kind, K3s, and Terraform, you've still got a somewhat scripted approach to kind of setting things up. Whereas I found that when I want to spin things up and down really quickly, if I use this tool, I can do it with a single command. So I can create that, and I just do JP up. It'll install my kube cluster. It'll run some Helm charts, install some jobs, configure some ingresses, and do all of that in a single command. And as that was coming up and down, and I was sharing it with people, that approach I found was the best for me. It's an approach. But I think using something like Terraform is a great approach as well if you understand how to use Terraform. But I would say check out using JumpPad Kubernetes clusters because you can create a multi-node kube cluster in Docker, and then you can just use Terraform, and then if you make a mess of it, JP down, it's gone. A minute later, it's back up.
Okay, thank you. Another question, sir?
Of course.
JumpPad, it doesn't have any state or something like that, right? It just reads the infrastructure that you created. It
has a state, and it has state because we need to do certain things. So, for example, you can mark a module or a resource as disabled, and that can be configured through a variable. So, for example, I might have a variable. Well, let me show you. I have a variable here, which is like, say, the number of nodes in. Oh, I destroyed it, didn't I? In Nomad. But what I can do is I can configure this here. So if I say I've got my Nomad or my Kube cluster running and I change the number of client nodes. When I do jump pad up, it's going to automatically reconfigure. So it is doing like a Terraform-like approach. It's dynamically reconfiguring my cluster. So for that reason, we use state, but also to be able to calculate the dependencies, because that was kind of the pivotal thing, because order of creating the resources when I was building my lab environment was really awkward. And in my humble opinion, and again, like okay, my salary gets paid by the people who create Terraform, but that is the thing that I love the most about Terraform. It's the not having to care about dependency and having that internal reference automatically created. It just saves you so much work.
Okay, thank you so much.
Pleasure. But it's local state, and there's no secrets, and it's only a dev environment, so if you commit it to GitHub, you're fine, because it's on your local computer, so they can't get you. Anybody else have any questions? 16 seconds. No? Well, I want to say thank you very much. I hope I haven't bored you. I hope this is useful. Genuinely, 4 years I've been using this on a daily basis, and it makes my life easier and allows me to experiment. So if you do anything, please seek me out. It's more than a pleasure to help. Thank you so much.